What's up, guys? We're going to continue here with Chapter 5, and today we're talking about parallel and perpendicular lines. Parallel lines are lines in the same plane that never intersect. That's an important part, same plane. Later on, you'll hear about something called skew lines. And those are lines that don't intersect, but they're not in the same plane. It's kind of a weird thing to think about. Parallel lines have the same slope. This is very important. Make sure you're copying down this entire slide here. Perpendicular lines are lines that intersect to form right angles. Perpendicular lines' slopes are opposite reciprocals. Now you'd be thinking, what on earth is that? Well, this is what it is. Two numbers whose product is -1 are opposite reciprocals. For example, 4 times -1 equals -1, or -3/4 times 4/3 is -1. Notice that if I made this a fraction, I flip it and then make it the opposite. Okay, so it's positive, so I flip it and now it's negative. And then that times this is -1. Or if it's a negative fraction, I would flip the fraction and then change the sign so it's positive. And then these two values times each other would equal -1. That is what an opposite reciprocal is. So that's for perpendicular lines. Very, very important. Here's our daily funny. How does NASA organize a party? They plan it. I love the look of that dog. That's hilarious. All right, so parallel and perpendicular lines. Make sure that you copy this down. This is a parallel line. It says non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. So here's the graph of these two things. Notice that the slope here is the same on both of these, and these two lines would continue in their direction, both directions, forever, and they would never ever intersect. That's what parallel means. So make sure you have that copied down. Writing an equation of a parallel line. It says a line passes through 12, 5 and is parallel to the graph of y equals 2/3 x minus 1. What equation represents the line in slope-intercept form? The quickest way to do this is to use point slope form. So I have y minus this y value equals the slope times x minus 12. I need to fix that. How many of you caught that when you saw that? Whoops. There we go. Get out of here. And back to yellow. Y minus 5. My apologies. And then I go ahead and just isolate the y value, which is pretty simple. I just distribute that, so I get 2/3 x minus 8. And over here I have y minus 5. So then I would just add 5 to both sides. And I get y equals 2/3 x minus 3. So there is a line that's parallel to this going through this point in slope-intercept form. All right, so hopefully you copied that down. That made sense to you. Here is one for you to try. Go ahead and pause, and the answer will be up in 3, 2, 1. All right, there it is. So again, you're using point-slope form, using the point and the slope, and you're writing it in slope-intercept form from there. All right, so perpendicular lines. Make sure you have this copied down. Two non-vertical lines are perpendicular if the product of their slope is -1. In other words, they're opposite reciprocals. Here is the graph of 1/2 x minus 1. Here's the graph of -2x plus 1. Notice that 1/2 times -2 equals -1. That means they're perpendicular to one another. They are opposite reciprocals. So here's how this works. It says, are the graphs of 4y minus 5x plus 12 and y equals 4/5 x minus 8 parallel, perpendicular, or neither? The way you do this is you have to get both of these into slope-intercept form. This one's already in slope-intercept form, so I just need to work on this second one. And then I compare their slopes. The slope tells me whether or not it's parallel, perpendicular, or neither. So I would need to, multiply everything by 1/4 or divide everything by 4. So those are gone. I'm left with y equals, this divided by that is negative 5/4 x, plus this divided by that is 3. So compare the two slopes. 4/5 and negative 5/4 are opposite reciprocals. So these two lines are perpendicular. Again, get it in slope-intercept form so that you can see the slope. All right, so go ahead and try this one. The answer will be up in 3, 2, 1. All right, so the answer to this one is neither. This slope is 3/4. This is 4/3. They're not opposite. They're both positive, so that's why this one is neither. They are reciprocals, but they're not opposite reciprocals. So be careful with that. That is neither. Hopefully you found that. All right, so which equation represents the line that passes through 2, 4 and is perpendicular to the graph of y equals 1/3 x minus 1? This is going to be very similar to what we were doing when finding parallel. Use point-slope form. So y minus 4 equals my slope, and then x minus my x value, and then get the y by itself. So I get y minus 4 equals 1/3 x minus 2/3. Add 4 to both sides. We get y equals 1/3 x plus 3 and 1/3. Hold on here. Wait, I made a mistake. All right, the mistake is it's perpendicular, so I had to use the opposite reciprocal. Let me fix all this. My apologies. But I'm not going to redo the whole problem because then I'd have to redo the whole video, and I'm not doing that. So let's try this again. My apologies. So here it's negative 1/3. So I want my y value, y minus 4, equals the opposite reciprocal of this is negative 3 times x minus 2. See how easy of a mistake that is? Make sure you're slowing down and paying attention and learn from my silly mistakes so that you don't make the same silly mistakes. Now we need to isolate the y. So I distribute this. I get y minus 4 equals negative 3x plus 6. Add 4 to both sides, and we get y equals negative 3x plus 10. That looks better. And there is our line that is perpendicular to this. Again, make sure that you're remembering that and paying attention and you're not making that silly mistake like I did. I hope some of you noticed that as I was going through it. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. There you go. That's your answer. You might have 17 halves for your y-intercept. That's perfectly fine. Those are the same thing. And let's keep going. All right, so solving a real-world problem. It says an architect uses software to design the ceiling of a room. The architect needs to enter an equation that represents a new beam. The new beam will be perpendicular to the existing beam, which is represented by the red line. There's the existing beam. The new beam will pass through the corner represented by the blue point. Here's my blue point. What is an equation that represents the new beam? So I need something that's perpendicular. So first of all, I need to identify what is the slope of this line. So to find the slope, I'll start right here because that goes through there. That's 0.8. And it looks like it goes all the way down here to this. That's very, very simple. Now there's other points on here, but I'm going to use this, the change in x, or the change in y over the change in x. So this goes down 8, and it goes over 12, which simplifies to negative 2/3. That's my slope. So to write a perpendicular equation, I need to use the opposite reciprocal of that, and then I need to use this point, which its ordered pair is 12, 10. So then I go and do what I've been working on so far. So I got y minus the y value equals the opposite reciprocal of this, 3/2, and then x minus 12. And then I solve for this. All right, so let's distribute my 3/2. Minus 18 plus 10. Y equals 3/2 x minus 8. All right, so that is how you would solve that. So you'd have to identify the slope first and then find your point. And after you have the slope and the point, you use the opposite reciprocal, point-slope form, to get it down into slope-intercept form. So y equals 3/2 x minus 8. And that's it for today, so I'll see you in class.